Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hi everyone, welcome back with me Ahmad Azhari in computer graphic class. This is our second meeting and I want to share about the introductions of OpenGL. So let's start it from the beginning. I will start the presentations before, okay, sorry. Okay, continue. The computer graphics is a branch of the informatics disciplines that studies image creations and manipulations with the computer or digitally. Computer graphics are often also known as data visualizations. As we studied before, on the few weeks before, we already studied about the disciplines of this computer graphics that related about the computer graphics, image processing, and also the pattern recognitions. The computer graphics sections. Among the computer graphics sections is the geometry, rendering, animations, and imaging. In these geometry sections, you can study about how to describe the surface of the plane. And the rendering, you can study about the algorithm for displaying light effect. And the animations, you can learn how to depict and manipulate movement either automatically or manually. And the last one, on the imaging sections, you can learn how to take and edit image. You can learn how to take and edit image. So what is an OpenGL? Okay, as you also know in practicums, the Open Graphic Library is a cross-language, cross-platform application programming interface for rendering 2D and 3D vector graphics. The API is typically used to interact with a graphic processing unit to achieve hardware accelerating rendering. Okay, so you now already know about the Open Graphics Library. Open Graphics Library is need to processing, to rendering, to use your graphical processing unit to rendering 2D and 3D vector graphics. All you need is software library for existing features in graphic software. Application programming, also known as API, Applications Programming Interface, the cross-language and the cross-platform. So I will let you know about the basics of the Open Graphic Library. OpenGL, also known as the Open Graphics Library, is developed at Silicon Graphics Computer Systems on July 1994. It is contains more than 500 commands for 3D interactive applications. The nature of the OpenGL is two. The one is the hardware independent and the second one is the software independent. Okay, all the basics, all the concepts, all the introductions of the OpenGL you can find in the website of officially OpenGL on https://www.opengl.org. So let's break out the basics of OpenGL. I will show you the little one, and you can learn much on the website. On the basic of OpenGL, 3D objects are built from primitive geometric objects. The primitive objects are kindly there are three primitive objects that normally are usually used. Okay, one is the point, or we also known as the vertex, and the second one is the lines. You can also see the lines is the 2 points that related each other. And the third one is the fields or the page. Yeah. And on the 3D object, you can also see the primitive image. Primitive image are including image pixel and also the bitmap data. Okay. On the OpenGL object primitive, you can also see the points, lines, strip, loop, polygon, triangle strip, triangle fan, quads, and also quad strip. Okay, as I also tell you about the points and the lines, the points is one a dot to the coordinate view, yeah, and the lines is one point, and they are including they are providing 2 points that are related each other. Okay, now um, I will show you the coordinate concept. In this OpenGL, in this graphical computer graphics, there are 4 coordinates. Yeah. First is the model coordinates. The second one is the word coordinates, and the third one is the viewing coordinate, and the last one is device coordinates. What is the difference? I will show you. The model coordinates is used to shaping the model. Yeah. The coordinate systems of the model coordinates used in shaping the model. And the word coordinates, the coordinates used in the environment where objects are placed. And the viewing coordinates used in projecting an object appearance based on the orientations positions. And the last one of the device coordinates, the coordinate system used on the display device. Okay, I will show the example of the coordinate concept. As we can see before, yeah, there are 4 coordinates, yeah, concept. The first is model concept, coordinates, the model coordinates. The second one is word coordinate, viewing coordinates, and also device coordinates. As I tell you before, the model coordinates used in the shaping the model. In the left one, the left, yeah, on your screen, on the left side, on the left one, yeah, is you can see the model coordinates that shaping the models into the triangles x, y, and z. Okay, and the word coordinates. The word coordinates is place the objects into the environment in the word environment. Okay, and the third one is the view coordinates. It is uh, projecting. It is changing. It is move your view, your perspective into the new ones. Okay, and the last one is device coordinates. You move your objects into the device screen, okay, on your device perspective, so you can see the object that you created, yeah, on the device that you have. Okay, there are some computer graphic terms that you should know. Okay, the first one is the rendering. The rendering is one of the process create image from 2D and 3D objects. And the second one is the rasterization, a method of creating image from 2D and 3D objects. The third one is the fragment data, yeah, what is data to create a pixel in a primitive object, primitive image. And the next one is the shaders. Shaders is code in a graphical programming language, yeah, shading language for executions on a graphic programming processor. The fifth one is the pixel, the smallest elements on the display, the smallest element in uh, graphic, yeah, in the graphics, in the computer graphics, the smallest element of the computer graphics. And the last one, you can see there is a frame buffer. A frame buffer you can imagine as a block of memory. There are many blocks of memory used for rendering. If you can, if you can imagine like a timeline or time lapse, you can see the block of memory used for rendering. Okay, let's move to OpenGL rendering a pipeline. OpenGL rendering pipeline is a sequence of a rendering process. The OpenGL pipeline rendering starts when you perform a rendering operations. The rendering operations requires the existence of properly defined vertex array object and a linked program objects or a pipeline program object that provides shaders of the programmable pipeline stage. Okay, I will show you the stage. Once started, the pipeline will operate the following order. Okay, this is how to render in OpenGL. The pipelining you can see in the right one. Yeah. The first, you should prepare an array of vertex data, then you try to render it. And the second one, the vertex process is started. Each vertex is processed by a vertex shader. The result of step 1A, yeah, the step 1, enters the tessellation shader. And this and the next one is the result of step 1B, yeah, goes to the geometry shader. After the all the process before, yeah, the output of step 2 is out of the primitive objects. You can find the primitive object as the output of step 2. The first process is create a primitive object. And the third one, you can see the vertex post-processing. In this process, the result of step 2 transform its position, apply clipping, and also the viewport transformations. Okay, each primitive objects now collected. Scan conversion and interpolations of primitive object parameters that produce a number of fragments. Each fragment is now processed by the fragment shader to produce a number of outputs. Operations per output sample. Now you can see the per sample operations, yeah, is scissor test, stencil test, depth test, blending, logical operation, and write mask. That's all the rendering pipeline of the OpenGL. Now you can see your practicums. Yeah, you can back to your practicums and see how the OpenGL process and compare it to this pipeline. Is it clear enough or is it not clear? You can write, you can find how the clear one, yeah, how the informations, yeah, the deep informations on the OpenGL website. OpenGL shader. In the shader, you should know there are 5 shader you should know. First is vertex. The second one is tessellation control. The third one is tessellation evaluations. The next one is the geometry and the last one is the fragment. As you can see, the vertex shader is used to receive vertex data. Vertex data information for color processing transformation is received by the vertex shaders. Tessellation control shader set the parameters for interpolations and the number of tessellations performed. Tessellation evaluations. In this process, in this shader, it determines the computations of interpolation used in geometry. And then After the tessellation evaluation shader, you can see the next one is the geometry shader. The geometry shaders change, adding the original geometry by expanding new verticals. And the last one, you can see the fragment shader. It receives fragment information for computational of pixel color positions on screen. Now, let's see how the OpenGL is performed on the operating system. To perform the OpenGL to the operating system, you need the independent software known as OpenGL. You need the OpenGL. And the second one, you need the intermediary, yeah, to connect the OpenGL to operating system. It is like GLX, yeah, for Windows, AGL for Macintosh Apple, and the WGL for Microsoft Windows. And the last one, you need the GUI or graphical user interface support. It is can provide by the Motif or the API Win32. Okay, next I will show the supplementary libraries. DGLU, OpenGL Utility Library. GLU OpenGL Utility Library makes rendering easy. Quadratic surfaces such as ball, cone, cylinder, yeah, and NURBS, non-uniform rationals, base spline and curves. And then GLUT, it is difference from the GLU. The GLUT is OpenGL Utility Kit. Okay, Utility Toolkit. It is used to make the programming on the OpenGL easier. Okay, it is also handled the events when you start use OpenGL. Okay, and the last one, it is used to make your animations moved. Okay, okay. When we talk about the OpenGL and API, there are stage of the applications layer. The OpenGL and API, you can see the first layer. So sorry, the top layer is start from the application program that show the end user interface. On the application program, you can see it is show your applications OpenGL that was running and starting and executing, yeah, on the behind, yeah, on the second layer you can see all the supporting supplements such as GLU that including from the GL graphics library, and also the OpenGL and uh, the support of the sorry intermediary, yeah, GLX, AGL, or VGL, yeah. And the last one is the software and hardware that support OpenGL running. So there are OpenGL data type, yeah. As you can see, data type is start from the integer, yeah, integer and floating point, unsigned integer. You already know about this. 8-bit, 16-bit, 32-bit, 32-bit floating point, 64-bit floating point, 8-bit unsigned integer, and so on. As you can see, when you learn about the C language, it is also known as the sign chart, sign short, integer, float, double, unsigned char, unsigned float, unsigned integer. On the OpenGL type, you can find with the GL byte, with the data type 8-bit integer. GL short is 16-bit integer. GL integer, 32-bit integer. GL float, you can find the 32-bit floating point. GL double, 64-bit floating point. GL U byte is 8-bit unsigned integer. GL U short is unsigned. U means the unsigned. 16-bit unsigned integer, and GL U integer is 32-bit in unsigned integer. Okay, when you see the instruction format, the left one, you can see the number of the components, the data type, the vector. Okay, when you find the format, the GL vertex 3 FE, yeah, so it means that you are using your data types of vertex, yeah. You start from points, vertex, yeah, the primitive objects. With the tree is mean the number of components, x, y, and z components of dimensions. F means the data type that you used in OpenGL. F means the float with the 32-bit, yeah, 32-bit floating point, and the V on the last one is the omit scalar form. Yeah, the scalar form, the vector. Okay, next we move to OpenGL color model. It is used RGBA, true color and color index color model. Okay, when you try to use the colors model, you can use GL color. Upon GL color, it is consists of red, green, blue, and alpha. Functions for mode color index you can see on the GL index. The color pixels is the value of the color is between 0.0 f float, yeah, sorry, 0.0 float until 1.0 float. The component A is an alpha. Alpha means the transparency. In the display mode initialization, you can use the code GLUT or GLUT index. On the last one, on the bottom one, you can see that when we try to set the green color, yeah, you can use the instructions with the GL color with the three elements and the floating point value. Or the color pixel value you can fill with between 0.0 float until 1.0 float. Okay, when you full your color pixel value, it mean that your color of the RGB is used, such as when we try to use the green one, you can fill the 1.0 on the middle one. So we can see that the color of the functions is the green one. So when you use the other color, you can combine the color between R, G, and also B. And you can also try to input your alpha or transparencies on the last one. Okay. OpenGL coordinate model. When using it, it is using the format X, Y, Z, and also W. X, Y, and Z, as you can see, as the axis one. Axis Y, axis X, axis Z. And the last one is W, is the coordinate of homogeneous coordinate x per y w, the y per w, z per W and also the W. If we define X, yeah, Y only, yeah, then Z is 1.0 and W is 1.0. As you can see, we can when we try to set the coordinate X with the 1, Y with the 1, Z with the O, and W with the 1. So you can look at this on the sample. You can use the vertex as the data types with the as the primitive objects, such with the point or the vertex 1, and the three dimensionals x, y, and z, and the floating point and the vertex. You can see we can input the x1 with the 1.0 flow, and y with the 1.0 float, and the last one with the 0.0 float. Okay, GLUT, the basic program. As you can see, how to use the basic program of the GLT. First, you can select the window type and create the display window. And the second one, initialize variables in OpenGL. Set the background color, initialize the light source, initialize projections. And next, you should try to handle this event by try to handle display, mouse, keyboard, resize the scene, and the other environment that support your programming. And the last one, you try to run a loop for looping the main event. As you can see here, I provide you, yeah, the sample program. You can see also the sample program on your practicums book, yeah. And the main program, you can see the top one, the void main, yeah, with the data type of integer and character, yeah. And after the main program, yeah, you can see the window of interface, yeah, and initialization. And next is event handler. You can display, reshape. You can use your keyboard. You can make these ideal functions, yeah. And the last one, you make its loop from the main program. You can see the program example in this in this program example in the environment declaration. You can see also at the program practical book, yeah, how to declare all the header, initialization, variables of transformation such as transition, rotations, and scaling. You can also create the object drawing functions. Yeah, you can insert the GL push matrix, GL pop matrix. You can also uh, see the transformation operations, rotation from the right to the left, and you can set object to the color, this color set to the green. You can also transformations of object rotations upside and down. And when drawing object, you must start with the GL begin and end with the GL end. Okay. When you create the functions of the showing the object, you can put all object will drawn in the functions display. First, you must clean and reset the screen buffer and make the positions of the camera view is set as your as your program will show. Yeah, you set the positions of the camera, and in this case you set also the x axis, y axis, and pause a z axis. Yeah, and call functions to draw objects, and can also the installation functions here. Can initialize lightning, texture, and camera views. And the last one, we can resize the window by use these functions. Yeah. And after that, you run the program by pressing the run button or F5 in your Visual Studio. Move and zoom object with the keyboard and show that your program has been running well. Okay, and now you can rendering the OpenGL, and you can see that your object has been moved, has been created, has been simulated well as your will. Okay, I think that's enough. If you have any questions related to this explanatory video, you can leave your comments on the Google Classroom and YouTube. Thank you. I close by reciting Hamdalah. Alhamdulillahirabbil alamin. Wassalamualaikum warahmatullahi wabarakatuh.